Dear students, I welcome you for the today's second part of the chemical engineering design to the chemical equipment design. In the last class, we have discussed the different topics related to the design objective, that is the need of any product, where the need from a customer is taken into account. Then the setting the basic design considerations, that is your basis of production, the material balance and energy balance aspects are needed for that. Then generation of possible design concepts, means what are the different ways by which either you can produce that particular product, or the different permutations and combinations of the various established processes that can be taken into account. The next, the fourth one is the fitness testing. For that, one is able to generate certain mathematical model, or sometimes the pilot plant scale operations that is also needed to generate the data and to scale up the process unit for that particular capacity, which has been decided in the point 2 of setting the basic design basic. The next fifth one, that is the economic evaluation, optimization and selection of the process equipments. This is the most important part of any production related processes, that is the economic evaluation. And similarly, the optimization of those processes, of those parameters, has to be done to maximize the profit. There can be the percentage of profit also, but to maximize the profit, we are generally going to optimize it on various different aspects. Can be the raw material aspects, can be the process parameters of aspects, can be the sales aspects, all these different aspects that can be taken into account for the optimization purpose. And finally, the detailed design of the equipment selection. So here the role of chemical engineers, detailed role of a chemical engineer that arises, the detailed designing and equipment selection. Then general consideration, that is you can call the anatomy of chemical manufacturing processes. So generally any manufacturing process which is available is divided into the 6 different stages. That is, first one is a raw material storage. Next is the feed preparation. Then the stage 3 is related to the reaction. Then the product separation. Then product purification and the storage, product storage. So the raw material storage. Generally, the raw material which is used in any production process, it has to be stored for a particular number of days. Again, how many number of days storage that is needed, that depends on the type of a product. Now, if it is a food industry, specifically say the soybean oil production, now for that purpose, one should be able to store the raw material, which is the soybean seeds, for an year or so. Means I have to purchase the raw material in a particular season which will be suitable for the processing throughout the year. However, if it's a milk product or a dairy, there the raw material storage that can be either 1 day, 2 day or 3 days, not more than that. So all these considerations of raw material storage, and in case of our petroleum and petrochemicals, generally it can be storage of 15 days to 20 days, that will be taken into account. So this raw material storage is one basic important. Not only that, the purity of raw material products, that is also taken into account, which is needed for a certain production process. The next step is the feed preparation. Then what are the feed preparations? What will be there? So raw material as it is, that can be used or cannot be used. It has a certain pre-processing or obtaining the certain specific temperature, pressure conditions. What will be the purity of raw material? So, and in what proportion these raw materials, certain catalysts, certain initiators, they are to be added. So that is what a certain feed preparation that is required. It is similar to that, say for example, any polymer production, say polyethylene terephthalate and the ethylene glycol, that is to be mixed for the production of PET. So polyterphthalic terphthalic acid and ethylene glycol, that is to be mixed in a certain proportion, or slurry that is to be prepared, say in a proportion of 2.3:1. Then I have to develop or bring those raw materials to a process conditions. So what should be the temperature of this feed, which is going to a reaction vessel? There can be the single reaction vessel or can be the multiple reaction vessels also. That means certain amount of reaction that can take place in a one reactor, means whatever the percentage conversion I require. For example, if I require the 95% conversion, there are certain processes in which the 95% conversion can be achieved in one stage. Those reactions, they are fast reactions, but there are certain reactions which require the stepwise conversion, which requires the stepwise removal of sometimes water which is generated into the process. That is your certain reactions, say this polyethylene terephthalate reaction, which is nothing but the terphthalic acid and the ethylene glycol. It's a esterification reaction. In this esterification reaction, the water molecules, they are generated, and for the polymerization purpose, you are going to remove this water molecules which is generated into the reaction. So it is carried out in a stepwise manner. That is, you convert the first 30% in one reactor, then 80% in the another reactor, and then the conversion of the reaction that increases to the 95% into third reactor. Again, that depends. Some processes require the 5 reaction vessels also. So it is all dependent on the type of a reaction, where how many reactors that is required. The next is, once the reaction that has taken place, then the product separation. This generated or developed product that should be separated from the raw materials and the side products or the side reactions which are generated. Now you can see here that the generated raw materials, they are going to recycle of the unreacted raw materials, and whatever the byproducts which are developed, they are to be separated out, and the some waste that will be generated into the process. So in the unit of a product separation, where I am going to remove the raw material, unreacted raw materials, then whatever the side products or the byproducts that is generated and what is the waste that is generated, all these three things are to be removed, so that I will get a certain percentage pure product. And this, once this product that is obtained, whether its product purification is it sufficiently pure, or its purity has to be increased. Again, the cost of the product of pure product that increases drastically, or you can say exponentially. Generally, the product purification and the cost of product, that it increases exponentially. As you increase the purity, your cost of production that drastically increases after a certain limit. So whether I am able to afford this cost of purity product, or can I manage with a low purity product which is available at a lower cost. So again, that difference is there. And then finally, the product storage. So all these different units or the 6 stages, that is whatever you have studied in the organic or inorganic process industries, it is all divided into these 6 stages. That is the raw material storage, pre-processing of these raw materials that can be there, related to its purity, composition, process conditions, all that is related to the raw material and the feed preparation aspects. Then reaction that is going to take place. The next is the product separation. What in product separation you are going to remove the unreacted components, then the different byproducts which are generated or from the side reactions, and if there is any certain waste that is available. Then next is the product purification and the product storage. So all these 6 steps which are essential for any chemical manufacturing process, it can vary a little bit, but almost all these stages they are required. In sometimes this food feed preparation that can be avoided, or you are putting raw materials directly into the reaction vessel. If the reaction temperature, pressure conditions of compositions or purity issues are not there, then you are directly sending raw materials into the reaction vessel. It can happen. Then the only side reactions are not there, and if the unreacted material is not there, that means my percentage conversion is say 99.99% conversion is there, and there are very no side reactions are there. Then you will get the pure product. So that pure product then requires either bringing it to the solid form or liquid form, whatever the form it is required. So the obtaining the desired form, then that goes to the storage. So all this is the basic chemical manufacturing process which is typically used in the chemical industry. Now, what can be the general organization of chemical engineering projects? That is the overall project when you talk, because we are now presently talking related to the overall organization, to the role of a chemical engineering or chemical technologies. So generally the product specifications means the basic requirement, and from the need you are going to define the certain values, the rate of production, how much quantity that is to be produced. Then initially any general project, that is initial evaluation has to be done for that project. Then the process selection has to be done for that process, and the preliminary flow diagram. Now this preliminary flow diagram that is related to this or is little bit detailed in this direction. When you talk related to the process selection, there the process when we select, it already incorporates a defined flow diagram. This flow diagram is a very preliminary, it's a general. So all this basic design objective and stating the design basics, that is related to your project specification. The next thing is the initial evaluation, process selection, and the preliminary flow diagram. That can be done in your generation of possible design concepts. So this is all related to the generation of possible design concepts, where the initial evaluation, the process selection that will be there, and the preliminary flow diagram analysis will be there. The next is the basic design, yes, the possible design concepts, the basic design data that will be also there. So the material and energy balances in this initial evaluation, one has to carry out the material and energy balances, preliminary equipment selection, and the design, that is from this preliminary flow diagram. One has to preliminary equipment selection basis, rough basis, and first initially that is to be done. And after that, at this stage, the detailed design processes that can be done. Here, the detailed analysis of the processes that has to be taken into account. And this is the preliminary equipment selection and the design that will be done. Then the process flow sheeting that is to be done. So here it's a preliminary flow diagram we are taken into account, like the general consideration. These will be your prerequisites of pre-processing. Then you will be requiring certain processing. That means the processing is related to the reaction. Pre-processing is related to the feed preparation, and the post-processing, which is incorporating the separation and the purification processes. So this is the simple preliminary stage evaluation. Now the preliminary cost estimation and then the authorization of the funds. Once you get the preliminary cost estimations and the authorization fund, then and only then you are detailing out of any process that gets started. Without the funds, the detailing of the process that is not carried out in any industry. So this once you get the funds, then the detailed process design has to be taken into account. So all the detailings starts from after the preliminary cost estimation and the fund availability of the fund. So I have all jugaad related to the funds. Then and only then the detailed process design has to be taken into the account. Then details related to the flow sheet, that means, and the piping and instrumentation diagrams that is to be prepared. These are simultaneously worked and interlinked also. So the flow sheets has to be developed. Then the chemical engineering equipments you will be needed, or the process equipments you will be needed. The detailing of that, what volume, what specification, what should be its head, what are the different diameters of the flanges, what should be its thickness of the flange, what should be the thickness of the vessel, what should be the thickness of the head, then what is the agitator that is required, which type of the agitator you will be requiring, then what should be the shaft diameter, what should be the motor to drive that shaft. So all this detailing has to be taken into account. Then the design and specifications has to be done. So what must be the motor specification? What must be the shaft material, and what should be its diameter, and what should be its strength and stresses that can be developed. So detailed analysis has to be done after the funds that will be available. Then the different unit operations you will be requiring, different heat exchangers, detailing out for that. Then whatever the other miscellaneous equipments which are needed, like your separators, sometimes cyclone separators, gravity separators that will be needed. Then the material selection and the process manual, development of the process manual. So all these things that is to be carried out in details, and simultaneously the process and instrumentation diagram that is to be done. So instrument selection and their specification, then the procurement of the pumps and compressors and selection and certain specifications. Pumps, almost all industries you will require for transportation of the materials, or when it's a liquid material, then you will pump it with the pumps, and if it is conveyed solid material, sometimes that can be conveyed with the compressor or conveyor belts. That again depends on the selection and the raw materials. Then you will be requiring a vessel designing that will be taken into account, and then the heat exchanger designs or the other unit operations designing part of the other unit operations that to be taken into account. So all these are your basic chemical engineering operations. But besides that, you will be requiring utilities and other services also. Now, what are the utilities? Generally, you require the water for certain cooling purposes, cleaning purposes, for the then your air that will be required, air that can be the instrumentation air, or that can be compressed air, or sometimes you require the nitrogen for flushing purposes. So all, then you will require the steam at what pressure, at what temperature you will be requiring the steam. Is it a low pressure steam or is it a high pressure steam? Then after the steam generation, you may require the cooling waters, specifically if the cooling towers are there. In case of your heat availability of the heat exchanger, it can be a cooling tower which will be available in the industry. So all these are your utilities that is to be taken into account. So this is the generation. After that, the electrical and motor switch gear details, where you will be requiring the electrical engineers, then the piping design, where you will require the mechanical engineers, or specifically the piping engineers, piping in details of the persons who are knowing the details related to the piping design, that can be taken into account. Then your structural design, which is generally carried out by your civil engineers. Then plant layout, that is to be taken into account. Where should be the location of the plant, where should be the location of the utilities, where should be the location of the raw materials, where should be the location of the products. Then your administration building, canteen, all these facilities has to be in a specific or defined location. So plant layout, that can under that, all these different things which are taken into account. Then the general civil work, foundation work, certain drainages, roads, etc. All the detailing of this taken into the account by the civil engineer, and his structural design, that will be also generally carried out into by the civil engineers. The next is your building constructions, offices, laboratories, control rooms, all this related to the buildings. So after that, the project cost estimation and the capital authorization. So project cost estimation, in the previous stage also, we have taken into account the total equipment of the cost that will be taken into account, and the availability of the authorization of the funds. Preliminary estimation, and now this is the total project cost estimation. Then purchasing of all these equipments and procuring and installation of these equipments has to be done. Then the raw materials from the contractors, or what will be the source of the raw materials, that has to be taken into account. Then all this, after that, the construction of that will be there. Then the startup, once the all units and equipments are there at a proper position and they are all interconnected, then the startup that can be taken into account by considering the operating manual. So operating procedures, standard operating procedures are to be followed for the startup of any plant. Then its operation, that is the production process, will be there, and finally it goes to the final product that goes to the sales. So this is the general organizational structure that will be there for our chemical engineering projects. So all these are the project considerations that will be taken into account. So project organization is the another concern which is starts from the process evaluation, process selection, then process evaluation and the flow sheeting, then the equipment specifications, all these three, that is related to the process selection. Then the second is the construction section, that is the construction and the startup parts will be there, and all they are going to report to the project manager or project concerned, the head of the project, that is has to taken into account from selection to construction to procurement section and the specialist design section. So all these things, they are concerned with the project manager. This is the most important team which will be working in any organization for the project development or the plant establishment. So process selection that incorporate the construction, procurement selection and the specialist design section. So all they are interconnected. Then when you talk the specialist design sections, then it incorporates the vessel designing, control and instrumentation design, compression and turbine design. These are the basic things which are generally available. In besides that, the heat exchanger designs, generally that is what is required. The heat exchanger or certain utilities requirement, that will be also there. The boiler that can be there, which you study in your plant utility. So all these considerations, plant utility, then you study related to the boiler, steam generation. And you will be also requiring the air or cooling water or drinking water. So the different types of the water, different types of the air, and the different types of the steam, that comes generally under the utilities section. Then the piping selection and the valves related to the basic electrical. So all this work has to be managed by the different contractors or by the different engineers, which can be the civil engineer, electrical, mechanical, instrumentation. So where and how your understanding related to the different engineering aspects that is needed when you globally talk related to the any project. Even again, I am saying that for a chemical engineer, if it is a chemical plant, chemical engineer can reach to the higher level if he knows the fundamentals related to the other branches of engineering, that is mechanical, civil, electrical, instrumentation and computer engineering. All these are needed. So upon only we study related to the chemical engineering, but whatever the knowledge you gain it from the industry related to the different branches, that is very much essential. Unless and until you develop your knowledge related to these aspects, one cannot grow to a faster level. Rate of growth will be restricted if you will restrict your knowledge of the other branches of engineering. That will be found to be. So this is all related to the journey of a chemical engineering to the